Hello everyone, hope you all are well. Today we are going to discuss register transfer language. Let's see the topics we will cover under this section. Micro-operations. Micro-operations. The operations executed on data stored in registers are called micro-operations. A micro-operation is an elementary operation performed on the information stored in one or more registers. Example: shift, count, clear, and load. Types of micro-operations. The micro-operations in digital computers are of two types. Register transfer micro-operations. Transfer binary information from one register to another. Arithmetic micro-operations. Perform arithmetic operations on numeric data stored in registers. Logic micro-operations. Perform bit manipulation operations on non-numeric data stored in registers. Shift micro-operations. Perform shift micro-operations performed on data. Micro-operations continued. Arithmetic micro-operations. Some of the basic micro-operations are addition, subtraction, increment, and decrement. Add micro-operation. It is defined by the following statement. Contents of R1 plus R2 is transferred into R3. The above statement instructs the data or contents of register R1 to be added to data or content of register R2, and the sum should be transferred to register R3. Subtract micro-operation. Let us again take an example. In subtract micro-operation, instead of using minus operator, we use 1's complement and add 1 to the register which gets subtracted. That is, R1 minus R2 is equivalent to R1 plus R2 dash plus 1. Increment/decrement operation. Increment and decrement micro-operations are generally performed by adding and subtracting 1, 2, and from the register respectively. Logic micro-operations. These are binary micro-operations performed on bits stored in registers. These operations consider each bit separately and treat them as binary variables. Let us consider the XOR micro-operation and the contents of the two registers R1 and R2. In the above statement, we have also included a control function. Shift micro-operations. These are used for serial transfer of data. That means we can shift the contents of the register to left or right. In the shift left operation, the serial input transfers a bit to the rightmost position, and in shift right operation, the serial input transfers a bit to the leftmost position. There are three types of shifts as follows. Logical shift. It transfers 0 through the serial input. The symbol SHL is used for logical shift left, and SHR is used for logical shift right. The register symbol must be the same on both sides of the arrows. Circular shift. This circulates or rotates the bits of register around the two ends without any loss of data or contents. In this, the serial output of the shift register is connected to its serial input. SIL and SIR are used for circular shifts left and right respectively. Arithmetic shift. This shift assigns binary number to left or right. An arithmetic shift left multiplies assigned binary number by 2, and shift left divides the number by 2. Arithmetic microshift operation leaves the sign bit unchanged because the sign number remains the same when it is multiplied or divided by 2. Operation table. Symbolic designation. Description. Contents of R1 plus R2 are transferred to R3. Contents of R1 minus R2 are transferred to R3. Complement the contents of R2. 2's complement the contents of R2. R1 plus the 2's complement of R2. Subtraction. Increment the contents of R1 by 1. Decrement the contents of R1 by 1.